Alright guys, so here is our first problem, and on the graph right now we have two functions. We have the first one, f of x equals 3 to the x power, right? So I have that in red, and I have g of x equals 2 times 3 to the x power, and that's in green. So both of these are exponential functions, okay? And let's just talk about this a little bit. So when we look at our function in red here, we have f of x equals 3 to the x power. All right, there's a couple of things we can notice on the graph. The first thing you need to notice, okay, this function right here has something called a horizontal asymptote, okay, a horizontal asymptote. And what a horizontal asymptote is, right, we can give a definition of it. It's a line that continually approaches a given curve, but does not meet at a finite distance. So for example, at y equals 0, if I were to draw in a dotted line at y equals 0, let me go ahead and do that. Let me pick a color here that will show up. So at y equals 0, we have a dotted line, okay? Right? A dotted horizontal line, because at y equals 0, right, it'll be a horizontal line. Well, what's going to happen here? We can see that as this function, right, we're talking about f of x here, the one in red, as it approaches negative infinity, right, it's going to get closer and closer to this horizontal asymptote, or y equals 0. However, as it continues to approach negative infinity, it will not reach 0. It will get closer and closer to 0, but it will never reach 0. Okay, so that's the definition of an asymptote. You can have vertical asymptotes as well, and we'll talk about that in the future. But this is called a horizontal asymptote, all right? And it can occur at different spots, not just 0. You could have a horizontal asymptote at 2, 1, 3, negative 4, right? It doesn't matter. Same thing with a vertical asymptote. It could be happening vertically, all right? And again, we'll talk about that in the future. But in this case right here, we have a horizontal asymptote at 0. Again, as the function approaches negative infinity, it gets closer and closer to this horizontal asymptote, which is 0, but it will never reach 0. It will just continue to get closer and closer to our horizontal asymptote without ever reaching the actual value, which is 0 in this case. All right, the same thing is happening with g of x. It's getting closer and closer to 0, or a horizontal asymptote, without actually touching it. All right, so what we want to do here is describe the transformation that took place. Okay, so here we have our function, our original. We can call this our parent, right? We'll call this our parent function, because this is what it was originally, and then it went to this. So this would be our parent function. So we can just say parent here. And what type of transformation took place here, going from this to this? Well, using that table that I had up on the previous screen, okay, when we multiply the entire function, right, by an a value, right, by that value, so we multiply this whole function here by a factor of a. That a value is going to be 2, right? And when we do that, what is that called? Well, that's going to be called, right, a vertical stretch. Okay, so this is going to be a vertical stretch by a factor of 2. So the transformation that took place here was a vertical stretch. So let's write that down. A vertical stretch, okay, by a factor of 2. Okay, so a vertical stretch by a factor of 2. Okay, and that's it for this one. All right, so that was the transformation that took place. All right, let's try another one.